Okay. So here's the buffering mechanism. This is that first mechanism that we kind of just talked about. This is the easiest, the quickest defense against changes. Remember, this cannot correct or compensate. This can only prevent changes or resist changes to pH. This is probably the most important mechanism, which is bicarbonate. And this is one of the most influential extracellular fluid buffers, right? The creation of bicarbonate by combining the combination of bicarbonate with hydrogen acid, hydrogen ions or acid to produce bicarbonate, to produce carbonic acid. Guys, I'm mixing my words all up today. So the production of carbonic acid by the combination of bicarb and hydrogen ions, right? So that's the easiest, kind of quickest buffer to resist changes. Other buffers that are inside our cells, so intracellular buffers, are going to be proteins. So proteins can combine themselves with acid and resist pH changes, as well as phosphates. Phosphates can also bind themselves onto acid and create this substance, which can also resist any intracellular changes to the pH. So we have extracellular buffers, which are bicarbonate, and then intracellular buffers, which are proteins and phosphates. Okay, let's talk about some of the compensations here again. And we're gonna kind of go through this slowly because I think I kind of fumbled this on that first slide, but we're gonna go through this slowly in a way that makes sense and talk about how the lungs compensate and how the kidneys compensate. So compensation happens in minutes, right? We said it's a more immediate effect, and this is where we vary our rate of ventilation. So depending on whether the plasma has excess CO2 or too little CO2, the lungs can kick in kind of immediately and vary our rate of ventilation in an effort to either get rid of CO2 if we have excess CO2, or hold on to CO2 if we have too little CO2. So increased ventilation is going to blow off more acid, and that is going to decrease our plasma CO2, whereas decreased ventilation is going to hold on to more CO2 because we're blowing off less or decreasing our rate of ventilation. Okay. And just to kind of tie a practical application here, this is why usually if someone has a panic attack and they're kind of, they're kind of hyperventilating because of like an anxiety attack or some type of trigger, we usually ask them to breathe into a paper bag so that they can kind of inhale or reabsorb the excess CO2 that they're blowing off. Because if someone begins to hyperventilate, and this is not a corrective mechanism, they can throw themselves into a respiratory alkalosis by blowing off excess CO2 when the body does not need to be doing that. So we ask them to breathe into a paper bag so that they can inhale that excess CO2 and try to negate or correct any acid-base disturbance that could be creeping up as they, hyperventilate for a while. Okay, so let's look at a flow chart that kind of simplifies this here. So we have the initial stimulus being a decrease in plasma pH, which is increased acidity or excess hydrogen ions. And I always kind of mix those two things up. So a drop in pH is excess acid or excess hydrogen ions. And then that is going to stimulate our peripheral chemoreceptors to increase ventilation. So our receptors are going to detect that the PCO2 has risen, and that is going to stimulate the lungs to hyperventilate, and they're going to begin blowing off more CO2, and that will bring the plasma PCO2 back down, which will correct any acid-base disturbance in the pH by bringing the pH back up and correcting that disturbance. And then that will have a negative feedback on the initial stimulus. All right, so that was the lungs and how they can kind of immediately take effect or have compensation to acid-base disturbances. Let's look at the kidneys and how the kidneys come into play here. So the renal compensation, we said, is more of a third-line defense. It's going to take a longer time to have an effect, probably hours to even days. And the kidneys are going to regulate their rate of excretion of hydrogen ions and bicarbonate into the urine. as well as regulate the synthesis of brand new bicarbonate in the renal tubule. Excuse me. So the renal tubular cells have the ability to generate or synthesize new bicarbonate, as well as to reabsorb bicarbonate if the bicarbonate in the blood is low, or if there's an excess acidic state in the blood. So the effects of increased acidity are that the kidneys will increase the secretion of hydrogen ions, increase the reabsorption of bicarbonate, or increase the synthesis of new bicarbonate. And just to tie this in more practically so that you kind of understand what this means. If I have increased acidity in the blood, right, that means that there's more hydrogen ions in the blood. And so what the kidneys will try to do is get rid of those hydrogen ions by secreting them into the tubular fluid so that they can be lost in the urine, or I can try to increase my base to kind of balance out that excess acid. So I can reabsorb more bicarbonate into the blood, which will correct the excess hydrogen, or I can make new bicarbonate, which will also be a corrective mechanism. Okay.